1.2 types of data. The key concept, a goal of statistics is to make generalizations about a population. Different types of data tell us which statistical methods we should use in our analysis. They start us off with a couple of definitions, parameter and statistic, and they look almost exactly the same because they both say numerical measurement describing some characteristic, but one of them's talking about a population and one of them's talking about a sample. Remember from last time, a population was everybody and a sample was just some of them. Here's a mnemonic device that might help you to remember the difference. Population parameter sample statistic. That alliteration just maybe will help you to tell a difference between which one's a parameter and which one's a statistic. That's going to be one of the hardest things I think about this chapter is there are definitions, but they're so closely related. You got to really think hard about which one is which. Then they caution us and they say more than one statistic is called statistics. This is confusing because in the last section we defined statistics as the science of planning, studies, and experiments, and so on and so on. So use the context to decide if we're talking about a statistic, meaning a numerical measurement, or statistics, meaning what we're studying. Example 1, parameter statistic. There are 17 plus million high school students in the US. In a study of 8,505 students, 16 or older, 44.5% of them said they texted while driving at least once during the previous 30 days. And then they list the source. Which of the numbers are parameters and which are statistics? So remember, if you're talking about a parameter, you're talking about the population. And that means you're talking about everybody. So not all of those numbers in that problem are talking about everybody. But this one is. That would be a measurement that's talking about everybody in the population. 17,246,372. That would be an example of a parameter because it represents the entire population of high school students. Which are statistics? Remember, statistics is going to be a smaller set. It's talking about the sample. Statistics are numerical measurements talking about the sample. And so we can see that this number right here is a statistic because it's a number of the sample. But also this one is 44.5% of them. That's also talking about the sample, not the population. So a parameter is talking about the big number, and the statistics is talking about the smaller subset of people. A couple more definitions. I always learned it as quantitative and qualitative, but this book gives it as quantitative and categorical. Quantitative reminds me of quantity, and that reminds me of a number. It says numbers representing counts or measurements, aka numerical data, generally when we're talking about numbers. Categorical data, names or labels that do not represent counts or measurements. So, I mean, it says category right there, right? You're talking about categories. It's usually names or labels, but it's also called qualitative. Example 2, quantitative / categorical. Identify each of the following as quantitative or categorical. The ages in years of subjects enrolled in a clinical trial. Basically, you need to look at it and ask yourself if it's talking about a number. Are we talking about a number? Then yeah, that's quantitative. The genders, male, female, of subjects enrolled in a clinical trial. Are we talking about a number? No. So that's not. It'd be categorical or qualitative. The identification numbers 1, 2, 3, 4, blah, 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 to 25 are assigned randomly to the 25 subjects in a clinical trial. This one's kind of tough because we're talking about numbers, but the numbers don't really act like numbers. Think about your student number, your 450 number or your 811 number or whatever. That number doesn't really count as a number. I can't really do math with those numbers. They don't really tell me anything. It's really just a taking place of your name. And so these numbers right here, just like your student number, is actually going to be categorical. Discrete data and continuous data. If you took my finite class, a lot of the times finite and discrete are used pretty much interchangeably. They both mean countable. Discrete data result when data values are quantitative and the number of values is countable. Continuous data result from infinitely many possible quantitative values where the collection of values is not countable. So we're thinking about, is it countable, is it not countable? So a couple of examples: recording the number of coin tosses until heads shows up is an example of, think about this, okay? I flip a coin, it's tails, I flip a coin, it's tails, I flip a coin, it's heads. Can we count the number of coin tosses there? Yeah, that's discrete. Recording the height of a plant each week is an example of, well, I can't count the height of the plant, that's continuous. Example 3, discrete continuous. Determine which of the following are discrete and which are continuous. Each of several physicians plans to count the number of physical examinations given during the next full week. It literally says count the number. That's discrete. Casino employees plan to roll a fair die until the number 5 turns up. Well, we can count that. That's discrete. When the typical patient has blood drawn as part of a routine exam, the volume of blood drawn is between 0 milliliters and 50 milliliters. It's not like the milliliters go 1, 2, 3, 4, 5. It grows continuously. Think about the level of liquid as it increases or whatever. That is not discrete. That is continuous. To me, levels of measurement is the hardest part of this lesson. There are 4 levels: nominal, ordinal, interval, and ratio. And the problem is all of these are really, really similar. Okay, there are differences, but sometimes they are subtle. Nominal, data consisting of names, labels, or categories that can't be put in order. Think about nominal names. Ordinal, data that can be put in order, but computations like subtracting numbers are meaningless. So ordinal, put in order. Interval, data can also be put in order. Computations are meaningful. Data at this level do not have a natural zero. So think about what it takes for this. Put in order. Computations are meaningful. Do not have a natural zero. That means zero doesn't make sense. Okay, zero, another way of thinking about it is, does zero make sense or not? And then ratio, data that can be put in order. Put in order. Differences are meaningful. And there is a natural zero. Zero does make sense. So look at how similar some of those are. And that's going to be some of your hardest questions are going to be to try to determine which is which. There's that yellow box, and it kind of rehashes the definitions, but it also gives some examples. Examples of ratio include heights, lengths, distance, and volumes. Think about the ratio. Think about whether zero makes sense or not. Zero makes sense when you're talking about distance, length, and that kind of thing. Interval notation, temperatures. This one comes up several times. It doesn't make sense to talk about zero when we're talking about our body temperatures. Body temperatures are around 98, right? Zero as your body temperature, we don't know what that means, right? That doesn't mean anything. Ordinal, like ranks of colleges. Nominal, like eye colors. Now, I do want to point out, Nominal says you can't put them in order. But if you think about eye colors, we might have like blue and brown and green and hazel. I could put those in alphabetical order, but that doesn't really help me understand anything. It doesn't really matter if I put them in alphabetical order. So when I say put them in order, it's put them in some order that helps me understand the numbers or shows me something. Alphabetical order doesn't really help me do anything here. One way to tell between interval and ratio levels, or a couple of ways, I guess. Ask yourself if twice makes sense. So twice makes sense if it's ratio. Otherwise, if it's interval, it does not make sense. And for ratios to make sense, there must be a value of true 0. So you're kind of asking yourself, does the word twice make sense? Does the word 0 make sense? Example 4, levels of measurement. Classify each example of sample data by level of measurement. A, survey responses of yes, no, undecided. So your 4 choices are nominal, ordinal, interval, and ratio, and you have to really, really think hard about what the differences are. Okay. One thing to think about is like, can I do calculations with this? I can't really do calculations with that. Can I put these things in any kind of order? Yes, no, undecided. Putting them in any order doesn't really help me understand anything about it. So it doesn't really seem like it's in order. These are just categories. That's all they are. They're not even numbers. They're categories. So we would say that is nominal. B, survey respondents can answer with a number between 1 and 4. The number 1 represents an answer of I agree, 2 represents I disagree, 3 represents I don't care, 4 represents I refuse to answer. So again, you think about those numbers and think about if I can do calculations with those numbers. I could say 4 minus 1 is 3, but that doesn't mean anything in this problem. 1 plus 2, that's 3. 1 plus 4, math with those numbers doesn't really tell me anything. So I'm not doing calculations with them. Put them in order. I don't think about the I don't care, I disagree. It doesn't really matter what order those are. Really, those, even though they're numbers, they're really just categories. That's nominal again. College professor assigns grades of A, B, C, D, or F. I'm not doing calculations with those letters, but I can put them in order. That makes sense. It makes sense to put them A, B, C, D, F. It would be weird to put them in a different order than that, I think. So putting them in order, no calculations, that's ordinal. Body temperatures are recorded. Body temperatures. We could do certain calculations. Like if I could measure everyone in here's body temperature right now, and then I put you in order from highest body temperature to lowest body temperature. I could say, well, you're 2 degrees hotter than you, okay, and you're 4 degrees colder than everybody else. I could, add, subtract, or whatever. I can do some things, and those might help me to understand something about the numbers. And so I can put them in order. I can do calculations. But 0 doesn't really make sense in this problem. Nobody in this room has a body temperature of 0. That makes this interval. Important years in U.S. history are listed. I can put them in order. I can do calculations with it. I could say, 1492, Columbus set foot in the New World, right? That was how many years ago? That was whatever, 400 years ago, 450, 350, whatever. The country was founded in 1776. I was born 200 years later. We can do some math with that. We can do some calculations that would make sense with that. We can put them in order. That's interval. Heights of all students in class are measured. They're going to be numbers. We can put them in order. We can subtract. I can say you're 4 inches taller than you. This person's twice as tall as this person. Remember that test? Does the word twice make sense? I mean, it'd be weird if somebody was twice as tall, but you might be twice as tall as your little sister or something. But that's ratio. If the word twice makes sense, it's ratio. The amount of time students study for an exam is recorded. Is it possible that you studied twice as long as your neighbor? Twice makes sense there. That's ratio as well. I think those questions are kind of hard. Number 5, really the same question, except they only give us 2 choices, either ratio or interval. So again, think about, yes, question. I skipped one?
No, it's are you sure? Because ratio says that there's a 0 that starts, and can someone be a 0 height?
Well, I think that's a great question. The question was, does 0 make sense? Can someone be a 0 height? I guess in order for that to make sense, is you'd have to go back to like before you're born. You know, think about when you're an embryo, and maybe instead of thinking about students, maybe think about a plant. Okay, think about the height of a plant instead of the height of a student, and then you can imagine the plant, you know, is 0, and then it grows up to be a mighty oak tree or something like that.
But in this context, wouldn't it be interval?
I believe it's still ratio. I believe, you know, go back to here, and when we're talking about heights, we're talking about ratio. And so I believe me, I'm with you on the, it doesn't really make sense because none of us were ever 0 inches tall or whatever. So I think it's kind of a gray area, but to me, if I think about plants instead of people, it makes more sense when I talk about height. All right, great question. Let's move on. Number 5, determine whether data are ratio or interval. Time in minutes it takes students to complete a statistics test. Again, on this question, think about the word twice. Does it make sense to say twice? Might take you twice as long as someone else. That's ratio. Body temperatures. We've seen this example a couple of times already today. Body temperatures. Your body temperature is not going to be twice as high as somebody else's. That doesn't really make sense. Does 0 make sense for body temperature? I don't think so. This is interval. After that, we've just got a couple of definitions, so you guys can read through those. I don't think it's worth anybody's time for me to read a page worth of definitions, okay? But I do want to encourage you to do that. There are a lot of terms, and the terms are important. So read through those definitions, learn those terms.